All right, so solving nonlinear systems in the form mx plus b equals kx. So how do I solve this? Algebra, what do I do first? Okay, one more time, Mark. Multiply the x. Why did I multiply by x? Get what?
200 by x.
Okay. To solve, we have multiply by x because we want to get the x off the bottom first, right? Right, because it's hard to solve for on the bottom. So we get 10x equals 200. Now what do I do? Divide by 10. So x equals 20, right? Excuse me. Now how do I solve this one? Same way. So whenever x is on the bottom, what do we do first? Multiply by x. Does that make sense, Bree? Okay. Whenever x is on bottom, we multiply by x first. So 5x equals 35. So now what do I do? Divide by 5. So x equals 7. So those are my two solutions. Okay, those are my two answers. All right. Any questions to what I did? Any questions? Now I know that this is kind of a review of what we've done before, right? But that multiply by x part, that's something that students forget how to do. Okay? A lot of mistakes get made there. And that'll be helpful later on today, so that's why we started out with that. Now, you guys remember back during Unit 1, we did systems of linear equations? You guys remember doing systems of linear equations? Yeah? So we had to use substitution, elimination, or graphing to solve, right? Now, linear equations were only in the form mx plus b, so it's like 5x plus 7 equals 20 or something like that, right? And that was one equation. The other equation was like 5x plus 2y equals 30 or whatever. And you had to solve for x and y to find your solutions, right? Right? Well, those were only linear equations. Today we're going to look at systems of nonlinear equations. So one equation is going to be a linear equation. One equation is nonlinear. So here I have two types of equations, y equals mx plus b and y equals k over x. Which one's linear? Mx plus b, right? This one is linear. Okay. If I graph this, what's it going to look like? It's going to look like a straight line, right? So it could look like that if m is positive, or slope is positive, right? Or it could look like this if m is negative, right? Now this line can cross the y-axis anywhere, can it? Either of these lines can cross the y-axis anywhere. Which one tells us where it crosses the y-axis? The b. Okay, base center of b, that tells us where it crosses the y-axis. So that's a linear equation, right? What's this one then? Nonlinear, right? What is it going to make? Nope, parabolas have x squared in them, and the x's are on the bottom. All the way back from Unit 1. An insect. Goes in a cocoon. There we go. It's a butterfly. Right? It's a butterfly. Now, the reason we call it butterfly kind of has those two swoops, right? Kind of like wings, right? Now, this butterfly is when k is what? K is positive, right? If k is negative, how's it look? There's one right here and one right here, right? So the blue one is when k is negative. Now, if you're taking notes and you don't have two colors, maybe you want to dash the negative one, so that way you know which one's negative and which one's positive. Okay, that might be helpful. So this is the linear part, y equals mx plus b. This is the nonlinear part, makes a butterfly. Now we're going to look at a system of these two equations. Okay, so a system of these two equations mean we have y equals mx plus b and y equals kx, and somehow they're related, right? Somehow they're connected. Now if I have a system of equations, finding that solutions, what does that mean? Finding the solutions to the system, what does that mean? What am I doing? All the way back from Unit 1, right? Finding a solution to a system means I'm going to find the x and the y that make both equations Someone said it. Just got a little louder? True. Good. We're going to find the x and the y that make both equations true. Okay? So finding solutions means finding the x and y that make both equations true. Now instead of writing like that, x and y, I could write it x comma y, because that right there is a point, isn't it? Right? Isn't x comma y a point? Yeah? Now for a system of equations, this x comma y is where the two graphs do what? Meet. Right? What's the fancy word for that? Intersect. Good. So these solutions are the point of intersection. Solutions are the intersection of the two equations. It's the intersection of the two equations. Right? That's what our solutions are, right? Right? Now for this system, mx plus b, which is line, and k over x, which is a butterfly. One line, one butterfly, so either one green one or the blue ones, right? How many times could the green ones and the blue ones intersect? Okay. How many times could the green ones and the blue ones intersect? What do you guys think? You want to take a guess? How many times could this green one intersect the green ones down here? Doug? Once? Okay, once is a possibility. Twice? Twice is a possibility. Now we're tying this into parabolas, right? Right? We're tying this into finding solutions to parabolas, right, Brandon? Right?
Oh, yeah.
Okay, so how many solutions can a parabola have? We can have two solutions, right? That means the parabola crosses the x-axis how many times?
Or
Twice, right? Two solutions for a parabola looks like this, doesn't it? Right? What's another possibility for a parabola? One solution. What does that look like?
not crossing the x-axis.
Just kind of bumps into the axis, right? Right, that's one solution, isn't it? And what's the last one, Matt? No solution means we don't touch our axis at all, do we? Okay. So, two solutions, one solution, no solutions. Right? So, how does this parabola tie into the linear and nonlinear stuff? How many solutions do you think there are here? How many possible? Two? You think two are possible? Yeah? You think one is possible? Yeah. You think zero is possible? Yeah. Okay, well, let's see what they look like. Okay, using your calculator or using an online grapher, all right, we can plug in, we're going to look at negative 4 over x and negative x minus 4. So if you have a graphing calculator, plug into one equation, y equals negative 4 over x, and the other y equals to negative x minus 4. And if you look at that, all right, if we look at that, here I have a butterfly and I have a line, right? Oh, maybe I should put the camera. Okay. We have a butterfly and a line. Now, how many times does the line hit the butterfly? Twice. So how many solutions are there? Two. So the possible solutions, the possible number of solutions there are two. So finding solutions means solutions at the intersection of the graph. We can have two solutions. Which means we have a butterfly and a line hits it twice. Right? Two solutions, we have a butterfly and a line hits it twice. Now if we go back to our equations and we change the minus x to a plus x, or a positive x, and then graph it again. How many times did that one hit? How many times, John? Once. It hits once, right there, right? Just kind of comes up and just touches it once, doesn't it? Right? So how many solutions would that system have? One. So one solution, we have our butterflies, and the line comes up and just hits it once. Right? Now, if I'm going to have no solutions, then where do you think our line's going to go? In between them. Right? So no solutions. Like if I have my graph of my butterflies, okay, and our line goes in between the two butterflies. Right. That doesn't hit it all, does it? No. So there's no solutions. Yeah, check on. We're just doing a lesson online.
So what do I do with correctors?
Yeah, correctors are due Wednesday. They're on my desk back there. All right. So no solutions if we don't cross the axis. Or sorry, if we don't intersect the graph at all. All right. Just do all of them, Josh. Okay. All right. The answer key is online. Okay. Here. Come grab this. Okay. Here's a self-assessment. All right, Josh. I'll also put what we're doing tomorrow online, and I'll put our new OE online too on the Facebook page. All right. All right. So, any questions about how I know there's two solutions, one solution, or no solution? Any questions about that, guys? Okay. To give you an example of it with the graph, if we go back to our equations and we change this x, instead of having -4, if we just have y equals x, all right, and I graph it, then our line never hits our graph. Okay. If you didn't write down those equations, that's fine. I was just to show you examples. Right. That's okay if you did though. All right. Now, what do you think we're going to try to do today? Just pick out numbers of solutions and that's it? Yeah, that's what we're hoping, right?
Yeah.
No, we're going to try to find the solutions. Gentlemen, Brandon, go sit over there. Okay, go sit over there. Okay, thank you. All right. Now, Matt, you're shouting out trace for finding solutions, aren't you? Okay. Now, if I use the trace function, is that exact or is that an estimate? Estimate. Okay. Trace is an estimate. Okay. Now, if you want to use the calculated intersection stuff, you know how to use that. That's fine, but that also is an estimate. It's not 100% accurate all the time. Okay. Close enough. Now I'm looking for whole number answers, and you give me decimals. Okay. All right. So we're going to find solutions and make a sketch to the system. Y equals -4 over x, and y equals x minus 4. All right. So this is my system. Okay. I want to find the solutions or solution to this system. Okay. Now the first thing I would say to do is to know how many solutions you're looking for. Okay. So the first thing we should do is graph both equations and determine the number of solutions. So with your calculators, all right, maybe want to graph both equations. All right. Or use the meta calculator online link that I posted for you. All right, I'll graph my two equations. This was x minus 4. Graph. Okay, how many solutions does it look like we have, guys? 1. Okay, so I'm going to draw this because it tells me I have to make a sketch.
That's a good sketch.
Thank you. 4 years of college practice. All right. So there's my sketch. All right. So you can graph it on your calculator. You can see that there's one solution, right? It hits it once, doesn't it? Yeah? Yeah. Step 2. Now, I referenced the substitution elimination stuff we did last time, right? Right? Okay. We're not going to learn multiple methods for this one. There's really only one method to solve this. There's only one way to do it. Okay? It kind of takes a little bit of the substitution from before. Okay? In substitution, we solve for y in one equation, plug in for y in the other one, right? Right? Well, if I look at my two equations, they're both solved for y, right? Right? So I can plug in this for y over here, right? Right? Y equals negative 4 over x, right? So I can plug in negative 4 over x for y. Or what? Another way to think of this is I'm going to take my two equations and I'm going to set them equal to each other. Okay, so step 2, set the two equations equal to one another. Okay, and when you set them equal to one another, we'll get something like this: k over x equals mx plus b. That's why if you look at our title for today's lesson, it says of the form k over x equals mx plus b. Now is that what I have? K over x, right? Mx plus b. Is that the correct form, guys? Yeah. So step 2, set the two equations equal to one another. Step 3, we're going to get everything to one side. All right. Now, as I move everything to one side, I want to make an equation I'm familiar with. Right? In order to make an equation I'm familiar with, should I keep the x on the bottom or should I get the x off the bottom?
X off the bottom.
Get the x off the bottom, right? So how do I get the x off the bottom? What is that? Multiply. We multiply by x to get the x off the bottom. So then these two x's cancel. Now this over here, do I just multiply by one of them or both of them? Both. So it's like I have parentheses around x minus 4 and I'm distributing, right? Right? So this side ends up with negative 4. What does this become? X squared minus 4x. Right? So negative 4 equals x squared minus 4x. Is everything on one side yet? No, what's my next step? Add 4. So now I need to add 4 to both sides. So then we get 0 equals x squared minus 4x plus 4. Okay. Is everything on one side now? Yeah? Okay. So that's step 3. Step 4. Okay, now before we go on to step 4, what does this look like? An equation for what? A parabola, right? So I took a butterfly and a line, right? And somehow ended up with an equation for a parabola. Can you guys find solutions to equations for parabolas? Yeah. Can you guys find solutions to this? Yeah, we've been doing it for 2 weeks, haven't we? All right? So this isn't anything new, guys. All right? All it is a little bit of algebra and then something we've been doing for a couple weeks now. Okay? I know it looks different, okay? But it's the same thing, all right? A little bit of algebra, and then now we're back to our parabolas. Okay. How can I solve this? How can I find x for both of those?
Factor.
We can factor. What else could we use?
Quadratic formula.
Quadratic formula, right? And there's one last type. There's one last way we can use. We couldn't use in this case. If I didn't have this negative 4x right here, what could I use?
Special.
It's a special case, but what could I use here? Algebra, right? When we only have one x term, we can use algebra. So to solve for x, we can factor. We can use the quadratic formula. You might have to sing the song, right? Or we could use algebra. Now, algebra only works when there's only one x term. Okay? You can only use algebra when there's one x term. So what do you guys want to do?
Factor.
Factor? Okay, factoring sounds like fun. Let's factor. Okay?
Yeah.
Let's factor. Now, is it going to matter which one I use?
Yes.
No. Okay? If you use the quadratic formula, if you factor, we should still get the same answer, shouldn't we? Yeah. All right. So I'm going to factor this. So what are my factors of x squared? X and x. What are my factors of 4?
4 and 1 and 2 and 4.
Yeah, that's what I thought we were going to do. 4 and 1, 2 and 2. But we didn't look at our equation, right? If I have this minus here,
Oh, negative 2, negative 2.
good. We need the negative factors of 4, right? If I have a minus here and a plus there, we need the negative factors of 4 that end up with a positive. So they're both negative. So negative 2 and 2, negative 4 and 1, right? Okay, now I got to find the combination that adds to what?
Negative 4.
Negative 4x. So let's try x times negative 2 plus x times negative 2. Does that equal negative 4x?
Yes.
No.
No?
Yes.
All right. Yeah, it equals negative 4x, right? So did I find my factors? Did I find my factors?
Yeah.
Yeah. So then we have parentheses, drop down our x's, cross over our other terms. It doesn't matter in this case because they're both the same. But if they weren't, then it would. All right, so am I done? Did I find my solutions?
No.
No. All I did was factor, right? Now we did a good job factoring, but all we did was factor.
We need to set them equal to 0.
Good. Those factors, when I multiply them together, they still equal 0. So to find my solution, John was right. What do I do, John?
Set it equal to 0.
Now we set each factor equal to 0, and that's how we finish up solving for x. Okay? So factoring quadratic formula algebra, we got to make sure we find what x equals. Whichever one you use, you got to find what x equals. All right? So now I set each factor equal to 0. Whoa. A little ahead of myself. X minus 2 equals 0. Okay. How do I solve this one? Add 2. So 2 equals x. One solution. How do I solve this one? Add 2. So 2 equals x. I got identical solutions, didn't I? So how many solutions are there?
1.
1. Does that agree with up here?
Yes.
Yeah. So since my x's are identical, that confirms that we only have one solution. All right? It's this spot right here. Okay? And that's going to be 2 comma something. Are we done yet, though?
No, we got
No.
to put 2 in for x.
We got to know what that something is, don't we? That something, is it an x value or a y value?
Y.
It's a y, right? Now, if I have an x and I have y equals equations, how do I find my y?
Plug 2 in for y.
Not for y.
2x.
X, right? Plug 2 in for x. So our last step is plug x in and find y. So we take this x. Okay, if we have 2 different ones, we got to plug in twice. But since we have 2 identical ones, we just need to plug in once. So we take our 2 and plug in for x. Does it matter which equation I use?
No.
No, because at that point they're equal, aren't they? Okay, so we can do y equals negative 4 over 2. What do we get? Negative 2. Now if you tried the other one, y equals 2 minus 4,
Negative 2.
negative 2. All right, and that's kind of a good way to check yourself. Because when we plug in our x into both equations, we should get the same y. All right, so it's negative 2. Are there any questions? Are there any questions? Now, is this process going to change if there's 2 solutions?
Yeah.
No. Okay, same thing. We're going to find our x's. The other thing down here, when we have our x's, are they going to be identical?
So
No.
you got to plug.
So you have to plug them both in. So if I got x equals 2 and x equals 3,
You'd have to plug them in
Yep.
both. And
I have to plug in 2 for x, find my y, then plug in 3 for x, find my y, and I'd have 2 ordered pairs. All right? So this process doesn't change when there's 2 solutions or when there's 1 solution. All right? Now the one you're looking for is when there's no solutions, and that's why we graph it first. Because if there's no solutions, do I have to do all this stuff? No. If I graph them and my lines don't touch, okay, like in this case right here, if we graph them, it looks like this case right here. There's no solution there, is there? So you don't have to bother with the multiplication and the factoring and all that good stuff. All right. Are there any questions?
Yeah.
Yeah. What's your question, Rob? John, what's your question?
if you have 2 solutions and then you plug in say like 2 and 3 for x.
Yep.
You still have to plug your answer into x.
Yep. Once you find your x's, if you have two solutions, you have to plug both solutions in. So like if I had x equals 2 and x equals 3, I have to plug in 2 for x to find my y, and then I'd have that order pair to have 2 comma whatever that y was. Then I have to plug in 3 for x to find the other y.
Okay, but what if it's 2 and 3? Which solution would you use?
Well, there's two solutions then, right? If there's two solutions, that means we cross twice. So that means there's two possible. There's two possible. Yep. Well, there's two possible points. So you'd find this point by plugging in one of your x values and getting the corresponding y.
So we'll have
And you'd
2
find that
points
point.
instead of-
Yep. So you have two answers instead of one.
Okay, that makes sense. Because I thought you had to have them in all 1 point. That's
Nope. There's two solutions, and you gotta find 2 points. Okay. Any other questions? Now, I know the whole process is new, but are the pieces new?
no.
No. Is factoring new?
No.
No. Is algebra new?
No.
No. Is plugging into an equation and finding y new?
No.
No. Okay. It's taking things we already know and it's kind of smashing them all together to make something new. All right. You guys think you can do it? No?
I'm just kidding.
All right. I think you can, right?
I know.
All right. So I want you to practice. I want you to try y equals 6 over x and y equals 2x minus 4. Okay. I want you to try those ones. All right. You can factor. You can use quadratic formula. You can use whatever you want to find those. Make sure you graph it first, though, to see how many solutions there are.